بسم الله الرحمن الرحيم. مستمعينا الاعزاء، مرحب بكم في فيديو جديد. النهارده ان شاء الله هعرض لحضراتكم الويلدنج تكنيكس في البايب لاين. ده الستاندرد اللي المفروض ان كل الشركات تكون ماشيه عليه، بحيث ان احنا نضمن ان يكون عندنا انتاجيه سريعه وعندنا بروجرس عالي لكل بايب لاين. هنبدا ان شاء الله نعرض لحضراتكم الفيديو اللي موجود.
Pipeline construction projects today, like this 1,800-kilometer job connecting the gas fields of northern Alberta and Saskatchewan to the Chicago area, represent enormous efforts and capital resource commitments. With multiple construction sites over the length of the job, planning and coordination are imperative. Production progress must be accurately forecast and scheduled goals achieved. High-quality equipment and skilled personnel are mandatory. That's where the experience of CRC Evans automatic welding helps you make the difference. We pioneered mechanized welding over 30 years ago, and after more than 60,000 kilometers of pipe, we brought it to the state-of-the-art technology that it is today. Mechanized welding is the most efficient way of achieving high production rates in terms of welds per day. Although it offers numerous advantages over manual welding, the ones to remember are speed, consistency, and quality. Mechanized welding is able to deliver all this due to the machined, narrow gap compound bevel it uses instead of the standard API 30-degree bevel. Here's how. New pipe usually arrives from the factory with a standard API 30-degree bevel on the ends. Automatic welding uses a much narrower gap, and the root pass is done from the inside of the pipe. Pipe-facing machines modify the factory bevel to the narrow gap design. The bevel is machined perfectly square with the axis of the pipe, assuring a nearly perfect joint fit-up for every weld. Let's see how it works. As the two ends of the pipe are joined together, the internal welder lineup clamp holds the two joints securely. The welding heads then lay down the root pass weld from the inside. Internal welding is done automatically, controlled remotely by the operator. Now the first external pass is laid down. It's also called the hot pass. On top of that, the first fill is applied. Next, the second fill. Each pass fuses with the preceding one. The last fill pass fills almost the entire depth of the bevel, and then the final pass, or cap pass, completes the girth weld. The total number of the fill passes required will depend on the thickness of the pipe. The final product is a perfectly fitted weld joint, superior in every aspect to manual welds. Now let's look at how mechanized welding works in the field. A typical spread setup will start with a pipe-end preparation station where the beveling work is done. Following that is the banding crew. Behind that is the lineup root pass and hot pass station. In some cases, the two could be separate stations for greater productivity. Then come the fill stations. Their number will vary according to pipe thickness and productivity requirements. And lastly, the cap stations. The beveling station is generally located far in advance of the welding. A side boom or tractor places the pipe-facing machine into the pipe end, and hydraulic shoes lock it firmly into position square with the pipe axis. A rotating faceplate with as many as 6 cutters begins to machine the bevel. A normal facing operation is completed in 2 to 6 minutes, depending on the pipe wall thickness and the skill of the operator. Closer to the welding, a banding crew is applying steel bands to the pipe ends. These bands are the tracks that guide the external welding machines on their welding paths. The internal welder lineup clamp travels inside the pipe and is remotely controlled by a control panel on the reach rod. When the internal welder is positioned, hydraulic shoes clamp it in place in the pipe. The new joint is moved into position over the extending portion of the internal welder. When in the right position, the internal welder clamps the second joint into perfect alignment with the other. Then the internal welder begins to apply the root pass. After completing a weld, it moves forward to the pipe end. The reach rod emerges and personnel guide it into the next joint to be positioned. The first welding crew approaches the station to lay down the hot pass. Each crew travels with a portable tent, raised and lowered by a side boom or tractor. The tent is necessary to protect the welders and the work site from wind, dust, and weather. As each tent is lowered into position, the crew goes to work. External welding machines are clamped onto the guide bands, raised into position, and welding begins. Welding takes place simultaneously on both sides of the pipe. Each machine covers 180 degrees of the circumference. In a matter of minutes, the first pass is finished. External welders are removed. The tent is lifted, and the crew moves to the next station. A following crew then moves in on the weld to deposit the next pass. And so it goes. As each operation is concluded, the welding tents and men move on to a new assigned site. Thus, one after another, the crews move down the line in a synchronized pattern, and construction proceeds without interruption, as operations are repeated again and again over the length of the job. Our P200 external welder system brings advanced welding technology, offering superior speed, consistency, and quality. It features microprocessor control and programmable weld parameters for multiple passes. The P200 can be operated by a remote pendant and can be equipped with our innovative through-the-arc weld bevel tracking system. Suitable for gas metal arc welding or pulsed gas metal arc welding processes, the P200 is self-contained, carrying the wire feeder, travel carriage, computer control, and welding head. And it easily interfaces with most constant voltage welding power sources. A password-protected onboard microprocessor maintains precise control of welding parameters. Data storage and output features allow real-time weld data to be printed on-site or downloaded to a portable computer. And P200 external welders are versatile, since each can weld external root passes, hot passes, fills, or caps. This flexibility greatly reduces the number of spare machines and parts required for a project. For even greater efficiency onshore and higher productivity offshore, you'll want our dual torch welding system. By using 2 arcs instead of 1, it affords higher deposition rates per pass and greatly increases welding speeds. Its reliability and high performance is field proven on major pipeline construction projects, and its multifunctional design allows each machine to weld external root, hot, fill, or cap passes. This again reduces the requirement for spare parts and extra units. It's operated by a remote pendant and is an ideal platform for CRC Evans' proprietary through-the-arc weld bevel tracking technology. Designed for pulsed gas metal arc welding, it's a complete package with travel carriage, wire feeders, computer controls, and welding heads. It also uses a password-protected microprocessor to maintain precise control of welding parameters and interactive heat input limits. Real-time weld data can be printed on-site or downloaded, enhancing inspection and quality assurance activities. CRC Evans also offers the M-Series Flux Core system. As much as 3 times faster than manual out-of-position welding, it is ideal for use in tie-in welds. By adding an onboard processor, the M-Series can be computer-controlled. Of course, technology without proper backup can be very costly. That's why our program of Total Project Support is so important. TPS is our way of supporting you throughout your project. CRC Evans engineers can help you start out with the right mechanized welding system for the job. Our experts can train your personnel to operate the equipment skillfully and with maximum efficiency. We also provide support such as welding engineering, weld procedure development, on-site supervisors, and technical interface with the owning company.